Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 18 from Engineering Mechanics Statics 9th edition by G.L. Meriam, L.G. Craig, and Jen Bolton. Statement of the problem is: the signboard truss is designed to support a horizontal wind load of 800 pounds. A separate analysis shows that 5 by 8 of this force is transmitted to the center connection at C, and the rest is equally divided between D and B. Calculate the forces in member BE and BC. So the required member are BE and BC, and there is a condition that wind load of 800 pound is going to act that signboard, and 5 over 8 of this load, which is 500, is going to act at C, and rest is 300, so that is being transmitted equally at D and B. So out of that 300, 150 is going to act at D and 150 is going to act as B. So now the truss has been redrawn so that wind load is being 500 applied at C and rest of 300 equally divided at B and D as 150 pound and 150 pound at both ends. So as member forces in BE and BC are required, so this problem can be solved by using method of sections or method of joints. So method of joint starting from D is possible, but if we start from A or G, so then because both are pin support, so there are four reaction at both of the support, and if we start solving from the lower end, so then it is a statically indeterminate problem. So best method is either use method of sections or method of joint starting from D. So in this video tutorial, also going to show how to use Casio FX991CW to solve these truss problems. So steps to find member forces using method of joint: need to select a joint that has at least one known force, and then two or less than two unknowns. So if I look at joint D, so joint D that has one known now, 150 pound, and then there are two members at joint D, CD, and DE. So I can start with joint D. So, and then need to isolate the joint and need to draw a free body diagram, and then need to apply conditions of equilibrium. But all unknown member need to be assumed in tension, and after solving, if answer comes as positive, so that is in tension, and if it comes as a negative, so that is in compression. So I'm going to follow these steps to solve joint D. So joint D is isolated and one known load is 150, and member forces are CD and DE in tension. Now DE is an inclined member and need to resolve into its component, and for resolving into component, either I need a right triangle or angle DE, which is making either with the horizontal, vertical or horizontal. So now all vertical sides are of 6 foot, and then ABG is an equilateral triangle. So if I draw a perpendicular from B to AG, so it's going to divide AG into two halves, so 3 foot and then 3 foot, and similarly EBF now is also a equilateral triangle, and if I draw a perpendicular from E on BF, so then B to G horizontal distance is 3. So then this DCE triangle, its vertical side is 6 and its horizontal side CE is 3 foot a foot. So then I can use the triangle here with horizontal distance as 3 and vertical distance as 6 to find coordinate of component of DE. So that is joint D. and D is inclined member. It has one component DEX in positive x-axis direction and other DEY in negative y-axis direction. So there is one unknown in horizontal direction now. So I'm going to apply sigma fx equal to 0 first. So applying sigma fx equal to 0, so I have DE positive, 150 positive. So DE plus 150 is equal to 0. And rearranging DE is equal to minus 150. So next DE using triangle can be resolved into its horizontal component as horizontal side of the triangle divided by the diagonal. And similarly DEY as vertical side of the triangle divided by the diagonal. So then DEX comes as DE times by 3 over root 45 is equal to 150, and DE is calculated as minus 50 root 45 or minus 335.41. Once I have that DE, so then I will go to apply sigma Fy equal to 0. So sigma Fy equal to 0 is minus CD minus DEY, or CD is equal to minus DEY. So DEY is calculated as DE times by 6 over root 45. So DE is already calculated as minus 50 root 45. So by substituting the value and simplifying, CD comes as plus 300. So then interpretation of the signs, a positive value indicate tension and a negative value indicate compression. So the answers are DE 335.41 pound in compression and CD 300 pound in tension. So now CD and DE are calculated. So the next one, I can go to the adjacent joint C or E. At joint C, there are two unknown CE and BC, and at joint E, there are three unknown CE, BE, and BF. So I cannot solve joint E, so I have to solve joint C now. So I'm going to draw a free body diagram of joint C. So free body diagram of joint C is drawn. So CE and BE both are assumed as in tension. So at C, there is a load of 500 pound acting towards right, and then is CD is in tension. So it's very simple. So CE is going to be in magnitude equal to 100 and BC in magnitude equal to 300. So at joint C, applying sigma fx equal to 0, CE is positive and 500 both positive. So CE plus 500 is equal to 0. So CE is minus 500. And similarly, sigma fy, so BC is negative, CD is positive. So sigma fy equal to 0 is minus BC plus CD equal to 0. So BC is equal to CD, and that is plus 300. Now CD is negative, so it is in compression, and BC is positive, so then it is in tension. Joint C is solved now, and then now at joint E, so CE is known, so then I can isolate joint E to solve it. So free body diagram of joint E is drawn. So BE and EF are in tension. CE, so we just calculated, that is in compression 500, and DE previously calculated that 335.41 in tension. And then both of these triangles here, BE and that point, and EF a point, so they are right triangle with a similar side. So its vertical side is 6, horizontal side is 3, and its diagonal is 640 is root 45. So now I'm going to analyze this uh, joint. So now that's joint E. That joint E, DE is resolved into its component DEY upward and DEX towards the left. EF is resolved into component. One is EFX in horizontal towards right, EFY downward. Similarly, BE, one component is BEX towards the left, and the other component is downward. So now In horizontal direction, I have two unknown, and in vertical direction, I have two unknown. So I can either go for sigma fx equal to 0 or sigma fy. So now applying sigma fx equal to 0, so I have efx positive, ce as 500 positive, then bex negative, dex as negative. So I'll get minus bex plus efx plus 500 minus dex. So now DE is 335.41. Then I can substitute the values, and then BEX using the triangle and the rule here. So it is horizontal side over diagonal, so 3 over root 45. So minus BE times 3 over root 45 plus EF into 3 over root 45 is equal to minus 500 plus 335.41 into 3 over root 45. And then finally I'll get that minus 3 over root 45 BE plus 3 over root 45 EF is equal to minus 350. And then it is being simplified as minus BE plus EF equal to minus 782.634. So that is equation 1. Then I'll apply sigma Fy equal to 0. So BEY is negative, then EFY is negative, and DEY is positive. All are the vertical components, so they will be uh, vertical side of the triangle divided by the diagonal. So to get their components, so all that are being multiplied with 6 over 45. So D, and then here DE is known, so it will go to the other side, and then I'll get an equation in a simplified form as BE plus EF is equal to 335.410. So now I have two equations, so they can easily be solved by here elimination, substitution, and I'm going to show how to solve this one using calculator. I'm going to explain how to use calculator Casio FX991CW to solve simultaneous equation. If you press on and then home, so you need to go equation. An equation is a simultaneous equation with two unknowns. Then there is the system of equation. So BE in both of equation, I have put that first, so it is assumed as x in the calculator, and EF is assumed as y in the calculator. So BE is minus 1, then EF in the first it is plus 1, and then equal to minus 782.634, and then in the other equation BE is plus 1, EF is plus 1, and is equal to 335.410. If I press that equal, so all that equation is being input in the calculator. So then I'll execute it. So x comes as in the decimal 559.002, and then y comes as minus 223.612. So x is BE, which is 559.002 positive, and y is EF, which is minus 223.612 negative. So BE is in tension and EF is compression. So now required BE and BC are calculated. So BC is 300 pounds. So it is calculated as 300 pound in tension, and B is 559 pounds in tension, and then BE is calculated as 559 pounds in tension. So that is a solution to problem 4.